Hey there! Do you have too much mouse? Then you need UnMouse!
Hi there, my name's Bruce Rain from Brackers Creations, and this is the UnMouse, a small touchpad developed by a company called MicroTouch and released for Mac and PC in 1989 for $235 US. I don't think it was a big hit because it had come down to $189 less than a year later. The UnMouse uses capacitive touch technology, the same used in a modern smartphone. In 1989, there were already touchscreens and graphics tablets readily available, but the UnMouse was something else. It was like a mini graphics tablet that you could use without the need for a stylus. It had a resolution of 1024 by 1024, meaning it had over 1 million sense locations on the surface. Keep in mind this was about 5 years before Apple would start selling their Mac laptops with a trackpad. It was marketed as a space-saving device, a mouse replacement that wasn't as big and bulky as a graphics tablet and more ergonomic than a touchscreen. It could give you precise control while taking up much less space than a mouse mat. I recently acquired one of these and was keen to give it a try, but it came with a 110 volt US power supply. Here in Australia, we use 230 volts, so that would be my first hurdle. This item came up on Facebook Marketplace. The price wasn't too bad. It was only one suburb away from me. The only caveat was that it had a US power supply. And I didn't think too much of that. I figured I'd be able to sort that out. We'll talk about that a little bit later. Now, it was supplied with the original box, so that box is in pretty poor condition. So this is the cover for the box. This is the front and the sides. And then this is the back, and as you can see, it's seen slightly better days, but I'm not too fussed about that. Oops, just lost another bit of it. Okay. And this is the box, also pretty beaten up, but everything that needs to be inside is inside. So this is the UnMouse here. Now, I don't know if you can hear that, but it clicks when I shake it, and when I press it, it doesn't click. So there's clearly something wrong with that. That's going to need some work to fix that up. It has this little slit here, and this is designed for putting little function cards in, and I'll show you those in a moment. But before I do that, I want to talk about this device's dirty little secret. Now, if you look at this, this looks like a nice little compact unit. Oh, great. Nice and small. Wonderful. Great technology there. But let's have a look at this plug. That's not an ADB port, and yet this is meant to be compatible with the Mac. So what's all that about? Well, that's where we talk about this box here. This is the brains behind the unit. That is all the guts, all the electronics are in this. There's virtually nothing in this. This is virtually just a shell with some buttons. All of the brains in this. And there you can see our ADB port there. Then we've also got a little strange connector here for the power supply. And that's where we start to get into the problems with this power supply. Again, I'll discuss that in just a minute. These are all the original documents, which is fantastic. I was very glad that it came with all these. For some unknown reason, it comes with some Velcro. So some adhesive Velcro. That's great. We've got the floppy disk with the driver. We've got a user's guide. We've got a 90-day warranty. They obviously didn't have a whole lot of confidence in it. And then a lovely little personal letter from James Logan, president of MicroTouch, complimenting us on buying this and also offering some sort of, I don't know, some extra software or something. I'm not sure about that. I don't think that offer is still valid. And then we've got our little advertising campaign here saying, 3 reasons to put your mouse out to pasture. Yeah, so it's time for the UnMouse. The day of the mouse is over. And here are the little function cards I was talking about. So let's say we've got this one here from Microsoft Excel. You can get that. You can pop that in there. And then you've got your own little custom function pad here for using Microsoft Excel. We have got one here for home template, word processing, hypercard, drawer, desktop. Look at that. It's actually a little drawing of a desktop in case you don't know what they look like. Mac Paint, Excel 60 key mode, word processing 60 key mode, And we've got a few blank ones, so you can obviously make up your own custom ones. So that's very, very nifty. And we've also got a few stickers in here. I can't see myself sticking them anywhere because no one's going to know what it is. Now, I mentioned the power supply before, and this is the power supply here. And as you can see, it is a US plug. And it was my intention that I would just go and buy a replacement power supply and use that instead. Until I discovered, this has been opened up by me, by the way, but I discovered that this is plus minus 12 volts and plus 5 volts. So this actually has a plus 12 volts power rail, a minus 12 volt power rail, and a 5 volt power rail. So that's an odd one. Now, there are no real off-the-shelf solutions for that. So what I thought I would do is I have grabbed here a little Pico ATX. Now, the Pico ATX allows you to plug in just a standard 12-volt DC power supply and output a whole bunch of different power rails, including minus 12 volt, plus 12 volt, and 5 volt. So I am hoping that I will be able to use this to do all of the fancy converting, and then I can just stick a standard 12-volt brick power supply and then just power the unit like that, nice and easy. I think the very first thing I need to do is address the power supply situation. So I'm going to open this up and find out what the situation is with this wacky power plug. Just 4 gigantic screws to remove to get inside. Okay, well there it is. It's kind of odd. It's odd that it's not in there straight, but maybe quality control was on holidays. I'm not sure. I have got 3 leads coming out of this power connector. That's not really enough for minus 12 volt, plus 12 volt, 5 volt, and ground. We're sort of missing a plug here, so I'm not really sure what's going on. I'm going to have to go in and, I guess, reverse engineer this. I say that like it's something really impressive, but it's basically plugging this in and then using a multimeter. Inside this power supply, the different wires are labelled, so that makes life pretty easy for me. And this one is plus 5 there, and then this one is common or ground. Then we've got minus 12 there, that's the black wire. And then we've got plus 12 here, which is this kind of greeny blue wire. And then there's blue underneath here, which is ground. So what I'm going to do, I'm going to first of all check this black wire here. One would assume this is going to be ground. And so I'll check this against this red common wire. And yep, we've got continuity there. So that black is definitely ground. So that's all fine. Happy about that. This reddish sort of wire, I'm going to check that and check it with... Okay. Right, so the red one is plus 12 volts. That's good. Okay. The purple one is... Okay, so the purple one is minus 12 volts. So that's a really interesting one. So even though this power supply outputs a 5 volt power rail, it's not used. I mean, I'll just confirm that here. It's a plus 5 there. Yep. It's going to this little connector on the side here, which isn't going anywhere. No wires connected to it at all. So we need plus and minus 12 volts. We don't need 5. Okay. That's good to know. Now, here's the thing. This is so small, and I don't need this plug. I can remove the whole plug. So we're left with just this tiny little board here. I reckon I can actually mount this inside here with like some sort of 3D printed bracket, then run this plug through there so that all we'll have to do is plug in a 12 volt brick power supply and power it up like that. I actually think that's going to be a really easy and neat way of making this work. Time to remove this big connector. Okay, goodbye plug. Now I just got to clean these up a little bit, get rid of all the blobs. All right, Right, well, I've got rid of all the pins, so I've now just got this tiny weeny little board here. I now just need to figure out which ones I need. ATX pin out. So I've created a little jumper between pins 16 and 17, which should make this automatically switch on. And I'll have to check and see if that's working. Let's test a few. 3 volts. Minus 12 volts. 5 volts. This is wonderful, isn't it? Fun. 3 volts. Right, so the plan is going quite well. So I just need to create some sort of little housing or bracket that I can mount this in here in the case. And then I'll just need to run these wires to the relevant pins on this power supply. Too easy. I designed a nifty little bracket in Onshape and then 3D printed it with my Creality K1 3D printer. Okay, so here is my little 3D printed bracket. And while I originally thought it would go well there, you can see that it sort of gets in the way of this off-center power port. So it actually makes more sense to put it down here. And I can sort of just wedge it in there. I'll use a little bit of double-sided tape to hold that in position. I've set it up so that the board can just sort of click into place like that. I'll probably use a little bit of glue as well to make sure that doesn't go anywhere. And I've made little holes here for where the wires are going to come out. These are the wires here. The other advantage of having it on this side is that it's a little bit closer to where the wires are, so that's really good. I just need to stick that into place now and then solder the wires. What I also did was I 3D printed this little face plate. So I've got my little connector there and I'll set this up so that it will just sit inside there like that. Nice and flush with the edge of that. And I think that'll end up sort of just looking like a bought one when it's done. I can't remember which is which, so I'm gonna check with the multimeter. Let's test it. It's a good sign. Okay, let's check voltage. And I have got 12 volts at the red, and I have got minus 12 volts at the purple. So we are looking good. Now, those wires are done. I can pop this into my little container. Here we go. That is snapped in good and solid. That ain't coming out easily. That's fantastic. Now I need to attach this inside here. There we go. How good does that look? There's everything in position. All plugged in, cables there, cables there. Do I power it up? See what happens? I'll get the other part of it, and I'm interested to see if it actually consumes any watts. It may not do anything if it's not plugged into a computer, but I would just like to see. You know what? Something just occurred to me. ADB, Apple Desktop Bus, provides 5 volts of power. I wonder if it's getting the 5 volts from that, and that's why it didn't need 5 volt from this power supply. But if this was being used with a PC, they would have to use the 5 volts from the power supply because they would have been running it probably via serial. I think that's the case. So I suspect this is a power supply that would have worked either with the Mac or the PC version, but on the Mac version, they're getting 5 volts from the Apple Desktop Bus. That's my theory, and I'm sticking to it. I'll plug this in. I've got my little UnMouse here. I don't expect anything to actually happen because I don't have it plugged into a computer, but I'm just going to have a look, power it on, and see if we get any sort of current. I'm getting 0.092, so I'm actually getting more power consumption than if it wasn't plugged in. If I were to just unplug this now, it drops down to 0.28. So there is some power, some current being drawn from this unit. So that's a good sign. So this little network of mess here is the UnMouse on the right and then SE30 on the left. I have this connected up to power, and I'm going to fire this up in a minute. It's going to boot into system 7.1, and we're going to check and see if we get anything. I don't expect to get anything because it does need drivers to work, but let's just see what happens. We are booting into system 7.1 here. Now, according to the instruction manual, all I have to do to install the driver is copy the UnMouse control panel into the control panels. Right, now let's restart and see how we go. Well, the UnMouse is completely and totally unresponsive, so we're not getting anything from it there. I'm not sure what the issue is, whether it's a problem with the driver or whether it is an issue with compatibility with System 7.1. I believe this came out during System 6 time, so maybe it doesn't work with System 7.1. But I'm going to have to do a little bit of experimenting and try and figure out what's going on. If we go back and have a look at the control panels loading, you can see that the UnMouse icon has a line through it. That basically means it's not recognizing the unit, so I'll have to try and figure out why that's the case. After many hours of frustration, I finally came to the realization that the UnMouse was not getting any power. So I checked out my little Pico ATX and it is cooked. It is not outputting power anymore at all. So that part of the plan has not gone particularly well. I'm not sure if it was something I did or maybe I was testing voltages and accidentally shorted it or something, but this one is absolutely baked. When I run it now, this little chip here gets really hot and it doesn't output any power. So that's the end of that one. However, I do want to test this out. So what I've actually done is I've got an actual ATX power supply and I've got one of these little breakout things here. I've got minus 12 and ground and 12 volt connected up there. I'm going to switch this on like that. So we've now got power going to the UnMouse. Now, unless this is powered, the computer will not recognize it. That's one thing I have discovered. So now I am going to switch on the SE30 and I'm going to check and see if we get anything from the UnMouse. We're booting here into system 6.03 and I am going to move my hand to the UnMouse. Oh, look at this. Look at that. Will you look at it? As I said before, it's permanently stuck down. It's like you're pressing the mouse button all the time and that's why it's drawing a little square. But it is moving and I have to say it's moving incredibly smoothly. Way better than I was expecting for a device of this age. So now I have two problems I need to resolve. I need to come up with another idea for powering the unit, whether it's going to be another Pico ATX or whether I try and come up with something else that's not quite as delicate. And I also need to sort out the situation with this button being permanently pressed. So the next step is to try and diagnose the issue with this click. So we're going to have to open this up and have a look inside. Right. I think I see the problem. So it actually uses as the spring old bits of foam. My guess is they probably opted out of using a spring because of maybe an insulation issue. I'm guessing that this top section needs to be insulated from the base. So they didn't want to go with metal because it's conductive, and so they've gone with this old foam, which of course is now just crumbly yuck. So I'm going to have to replace them with something, one in each corner. That's the actual micro switch in the middle there, which gives us our click. So I'm going to have to clean all this old sponge off, and then I'm going to have to try and devise some other way of making that top bit springy. That's good enough. Well, I have printed these. Now, I don't know if these are going to work, but we'll see. So they are a little thing like that. It has some squish on it. I don't know how well it's going to last or how well it's going to work, or if it's going to be too springy or not springy enough, but I'm going to give it a try. So I figure I can just stick these down on the edges here with a bit of double-sided tape or some glue or something like that, and then we'll just see if they do the job. Only one way to find out. Right. Well, it's a fairly firm button press. I might be able to maybe redesign these a little smaller, or maybe if I made them a bit wider, they might have a bit more spring in them, but it's definitely not unusable. I'm feeling pretty good about that, actually. I might just have a go at trying to get these just a little bit springier and try with a slight redesign. So this is the old one on the right, and this is my redesigned one on the left. It's not as tall, and it's a little bit wider, so it has a little bit more spring in it. So we'll just see if that improves things. Well, that's pretty good. That feels really good, actually. Definitely better than before. It's just got, I think, just the right amount of tension behind it. These are printed in PLA, and PLA does have a tendency to lose its spring over time. So I may need to actually redo these in a different filament, maybe PETG or ABS, and they might last a little bit longer. But we'll see how it goes for the time being. Well, I think I may have figured out what went wrong with my Pico ATX. I had a look at the specs of this, and it actually says that it can only output 0.1 amps or 100 milliamps for minus 12 volts. Now, even though this device seems to only use about 35 milliamps, I wouldn't be at all surprised if that's the issue, especially given how cheap this was to buy. So I have to get rid of this and try something else. So I'm going to go with this instead. You can put whatever positive voltage you want into there, and then it will split it into positive and negative out there. There is typically a bit of a drop in that voltage, so we may actually have to put more than 12 volts in at this end, but we'll wait and see what happens. This is a little bit bigger than the other card, so I'm going to have to find some way of fitting it in here. I think I can still get it in here. I'll probably need to attach it to the top of the case, and I may need to remove some of these things. I don't need these terminal blocks on here. I can just solder the wires straight into it. I don't need this power switch. I can just solder that permanently on. It's really just the height of this sort of big fat capacitor there. And I think I can probably get this to just squeeze in there at a pinch. So I'll 3D print a bracket for this to sit in, just to keep it insulated mainly, and then I can double-sided tape it to the top. But before I do any of that, I need to check and see if this is actually going to work. So I've got one wired up here. I bought a few of them in case I break them, and I'm going to be putting 12 volts in, and then we're going to check and see if we can actually get this to work. I'm booting into system 7.1 here. I have done some testing with 7.1, and it does definitely work in that operating system. Okay, well, the little icon came up there. It had no line through it. That's a pretty good sign. It means it recognizes it. So I'm now going to put my hand onto the touch mouse thingy, and oh, look at that. Works beautifully. So that was just using 12 volts into this device, and I want to see what output I'm getting here. So through the positive, I'm getting 10.5 volts, and for the negative, I'm getting minus 15 volts. I don't know enough about this device, but it seems to just output minus 15 for the negative. But obviously there's a bit of leeway in this device here, in that it'll quite happily run with minus 15 volts and plus 10.5 volts. Maybe that'll make it blow up one day, but for the moment it seems to be working fine. So for the next step, I just need to remove all of these terminal blocks, solder everything into place, and then put this into a bracket and mount it onto the top of the case. The power doohickey is all wired up. It is sitting inside the 3D printed mounting bracket I made, and that mounting bracket is double-sided taped to the lid of this case. And if we pop this on here, it fits perfectly. So now we've just got the one power connector at the back for 12 volt DC input. I've switched it on and it's using about 132 milliamps, so I won't need a particularly powerful power supply. Let's take a little look at the control panel for the UnMouse and some of the functions that it has. Now at the top here we've got the setup menu either for cursor or power keypad. I'm using it as a cursor at the moment where my finger moves the mouse pointer. You can change it over to a power keypad and that's when you use these little templates that becomes a bunch of buttons instead of a trackpad. And so if we just click here on power keypad, you can go in and configure each one of those buttons as to what it does. You can also link it up with the MicroMaker software so that these buttons can then be turned into complex combinations of actions. You can switch between the cursor and the power keypad mode with this big red button here. So if you're wondering what that red button does, that's what it does. When you're setting up the cursor, you've got the option for absolute or mouse. If I go to absolute, and I'll put it here for pointing, wherever I put my finger, the cursor will jump to that location on the screen, like that. So this is essential if you're going to be using this for drawing something, for example. And so you can move around there. If I move my finger over to here, it'll jump across to the right-hand side. If we change it into a mouse-style control, like that, this means that it will remember where I was. So I can lift my finger up, move across to here, down there, and move like that. So this is much more like a mouse where you can lift the mouse up and move it to change your position. One of the downsides to this is because you're actually pressing the trackpad down to click on something, if for example I wanted to, I don't know, select something from this menu and my finger is a little bit too far down, I move my mouse down here and I've run out of trackpad, I can't get any further, and I need to let go and go a little bit further up on the trackpad. It's quite difficult actually to slide your finger while you're pressing the button, and I think that's one of the real downfalls of this device. So I'm going to test out the power keypad functionality now, and I don't actually have the software configured to match this template that I have in here at the moment, but I happen to know that the top left corner is configured for new. The way it works is when you press the red button, it'll flick over to the power keypad mode, but only for 2 seconds before it changes back into the trackpad mode. So you have to actually be quite quick. So I'm going to press the red button, then I'm going to tap up here, and it should create a new folder. Let's give it a try now. And there it did. It worked beautifully. And now we're back into the trackpad mode. And we can open that up and there's the new folder that we created. So that is actually quite clever. I could sort of see configuring this for working with specific bits of software. I could see this actually being a really good time saver. And the packing list says that this should have come with a stylus, but unfortunately mine doesn't have it. However, as long as you use something that's conductive, you can use just about anything as a stylus on this surface. This is just a pair of tweezers that I'm using, and you can see that it's working there. And obviously you could use that if you're wanting to slip something inside here and trace around it. The UnMouse is a fun little device, but it wasn't quite ready to replace the mouse. For starters, compared to the price of a mouse, it was bloody expensive. Even the Kensington Thinking Mouse, which I think was the Rolls-Royce of computer mice at the time, was $100 cheaper than the UnMouse. The UnMouse has great precision, the power keys and macro functionality are excellent, but it's a little clumsy to use. Trying to click and drag something can be quite fiddly, especially if your fingers are a bit sticky. I actually think the UnMouse could have been improved if it had a separate mouse click button below the touchpad, much like they did with the early touchpad laptops. Click with your thumb and navigate with your finger. In the future, I may even try to make a modification like this myself and see if I can make it easier to use. The other obvious issue with the UnMouse is the bulky controller and the need for an external power supply. The instructions encourage you to use the included adhesive Velcro to stick the controller to the back of your computer to keep it out of the way. Out of sight, out of mind. Despite the shortcomings of the UnMouse, there's no doubting the impact of capacitive touch on technology. All laptops now use trackpads, touchscreens, or both. And let's face it, thanks to the modern smartphone, we now all have capacitive touch devices in our pockets. I did a bit of research on MicroTouch and it would appear that they are still going today, specialising in touch screens for a variety of applications. I do hope you enjoyed this video on some forgotten vintage tech. Please consider giving it a like and subscribing to my channel. Thanks for watching.